All right, guys, welcome back to another KevCAM night class tonight. Tonight have Andrew helping out with any questions or concerns that come along for you guys. And looks like everybody in our list has been to the night class before, so I won't do the regular the GoToWebinar routine. But tonight we have kind of a special class. Darrin Bryant coming in here, and he's going to kind of go through and show you guys kind of tips that he has found out for us. Darrin, how long have you been at SolidCAM?
8 years.
8 years. So tips that kind of have, made his process faster. I know, Ronnie, you kind of brought this up a couple times too, and kind of how to get more efficient on the SolidCAM programming side of things. So with that being said, I'll kind of hoping to get some more guys in here. We got a few of you guys in here, but don't see too many other. But
we were joking because Darrin was the one giving the tips. People just said, I probably know everything that
yeah.
Darrin's going to share. So
I know more than
Darrin.
Darrin. Not bothered going.
8 years of what? No, Darrin, it'll be great. No, I'm excited to see what you got here, Darrin. Don't let us down.
Yeah,
I'm gonna be excited too. This is see what I come up with.
And we should have had Greg Payton here, but he's in mid-flight over to Germany right now for SolidCAM World, and he told me he was going to get the in-flight Wi-Fi, but he must have not gotten it, so we'll have to go without him tonight. Yep.
What a stingy guy there. We got to talk to him.
All right, Darrin, we're switching over to you now.
All right.
Well, now we got some more guys.
Do we see it? Yep. Saw a few people come in. We could wait one more minute or something and see if we get a few more, but it looks like we have, what, 5, 6? 1, 2, 3?
6 guys in there?
6, okay. All right, and I know several of you. I know George Lauer. Greg Malloy sounds familiar too. The only one I'm not quite sure about is Ben and Eric. Not quite sure if I've talked to them or not yet. All right, so we're looking at how to program faster. There's a lot of ways to do this, and I'm not saying I have all the ways to do this, but I'm going to show you what I do when I go in through a demo. I'm not going to give you the full demo or anything, but I am going to show you some of the areas where I make sure that I have set so that my system runs faster and it comes out the way I want it to look as I'm going. Is there anything else before I start, Kevin, that you need to?
No, that looks good. And like I said, guys, feel free to ask those questions, and I'll be pinging Darrin as well as we're kind of going through this. And just want to kind of get you guys to see how a good workflow setup will go using, templates, using the AFRM, the automatic feature recognition, using iMachining. It's pretty neat on how Darrin's got his settings set up. So have at her, Darrin.
All right, so I'm just going to quickly get in here and start a project. We won't have to talk about all that. Everybody knows how to start a project. But I will talk about also being accurate with your values when it comes to iMachining, because even if you don't want to go to the maximums that the machine can do, that's why you have a slider bar. And you can even dumb that down. I'll even show you a couple of tricks, and there's a lot of ways you can make iMachining run faster or slower. Let me just create a coordinate system on here, and then we're going to dive into editing my my machine list in here. So, all right, and I might as well just go ahead and pick my stock and my target real quick and be done with that, so we can move on. And I hope everybody can hear me. And if you ask a question, I'm not going to be paying attention to that, but Kevin will. So
yes, sir.
All right, we're going to use 3D model. And by the way, in case you guys are unaware, 3D model, out of all of these options here, is the only one that is fully associative, meaning if the solid model changes that you're using for a solid model, like this box right here, if it changes legs, widths, heights, or shapes, we'll also update to Toolpath, just like if you were to update or get a revision on your part. That's my preference. That's the one I like to use. But if you're not worried about your part changing, boxes, fine, or any other option. There's still some associativity. It's just that 3D model is fully associative, and the part that I'm trying to create is that. So the first thing I want to talk about real quick is your machine database and your material. Now, some people don't want to see all this stuff. There's no, at this moment that I'm aware of, and Kevin might be able to jump in on this, easy way of eliminating all the materials you don't want. other than going right click and deleting them individually.
Yeah,
Is there a way, Kevin?
In SolidCAM 2018, they have gone through and completely modified this database, so you guys can come in here and remove unwanted materials as you please in a mass list. Like
cool.
Darrin right now, he can go and click on that cast iron, and then he can actually delete it, but it's only one by one. Where in the 2018, you're going to be able to do this in bulk.
I'm having trouble right now. I'm right click. It showed up once, but for some reason it's not. Anyway, doesn't matter. You can individually delete them. But the machine is what I wanted to talk about here. Clearly, you have to put in your speed limit, or your spindle speed, your feed rate, and your max horsepower. Now, in order to, you want to be accurate with these values, because if you're not going to get the accurate values with iMachining. Even if you never say, I don't want to go to 12,000 because 10,000 is what they rate at, and then you have to have balanced tooling. Well, true, but the fact is that you want to be accurate here, and you'll use your slider bar. This is just a default level. And in case you guys haven't taken a look at this down here, this is very important. This used to be set at 50%, but it was hidden. Now it's been made available so you can mess with it. It has to do with ACP, axial contact point. The lower the value, the more iMachining pays attention to tool life. The higher the value, it pays attention to cycle time. So this is definitely something you want to play with. Now on the material side, you have a machinability factor. Like if you put in your own, you're going to be putting in the PSI of that particular material. The machinability factor, honestly, is like adjusting this by 500 or 1,000 either way. So the higher you go, it means it's machining very, very well. So you just keep cranking it up. Or what you can do is keep cranking that up. Just add more 1,000 to it. You know, go to 46,000, 47,000 until you find a really perfect optimal feed and speed there for iMachining. So, or you can play with this. I just think it's easier to do that. Anyway, moving on. Any questions about that? Hopefully not.
No, looking good.
All right. So we're going to move on to here. First thing I do when I'm creating the stocking target, and I kind of blew through that really quick, is I want to make sure that I have good values down here for the facet tolerance. This means a lot. In turning, it's set at 4 thousandths for the target. That's a really good value because it affects two things. It affects how accurate your silhouette snapshot of the side view of the part is, and it also affects what the part or the stock looks like initially and the part looks like initially coming into Solid Verify. So when it comes to the stock, I put it at 4 or 5 thousandths, it's fine, and same with the target, generally 4 or 5 thousandths, and I leave them alone. Now what that means is that when we go into, and I'll talk about that when we get in there, into the solid model, there's some other facet tolerance that has to do with the tool, but the initial look of the part coming into Solid Verify has to do with those two values we just looked at. So to speed up some programming time, templates are always the way to go. So if I come into, say, a face, now templates can be created multiple ways. They can be created individually, or they can be created, well, I don't have any other toolpath right now, but you can actually highlight the toolpath in the list, right click on it, and create a process template, which I can't do right now because I'm not actually selecting processes, but I'll show you that here in a second. So face templates, if you're not using them, or any kind of template, any kind of toolpath can be templatized, just like Probing or 5-axis, it doesn't matter. They all have the ability to create a template. This could, you could, absolutely set all your settings, or maybe you just always want one particular setting on, and you can have your template always come up. So every time you pull up face mill, you can have a very specific template come up. I don't do that on the fly, but you can do that. What I have done is set up some common facing that I do: contouring, hatch, one pass, spiral. It all depends on what the part looks like. Generally in a square, I'm going to use a hatch. Okay, sometimes I do a spiral. It just depends on what the part looks like. But this, as soon as I open it, is going to actually fill out everything except for geometry and levels, because it generally changes per part. Now, this face mill name came from, when I actually saved it. Now I can get rid of that and I can say new, or I can actually use that name and I can just edit it, and that would be fine too. Now, by default, it selects target. Now, here's the other benefit of picking a 3D solid as your stock. It always shows up as a drop-down menu item rather than having to pick a model, chain of face, or pick a face or chain of profile. It's automatically here. So you get an extra benefit out of using that.
Darrin, can I stop you just for 1 second here?
You bet.
We do have one question, is when you were playing around with that stock and the target with the facet tolerance, is that affecting the toolpath quality for that particular part?
No, not at all. It's got nothing to do with G-code in any way, shape, or fashion. It has to do with how pretty the part looks, kind of like the facet tolerance in SolidWorks. So you can have, like if we zoomed up on this part right here, and we took a look at these corners, you can see the faceting right here. That's just a visual of what you're looking at. Now, obviously, if you go with a really tight tolerance, when you're playing around inside here, your rotation could be slower, your computer can run slower. So what you're looking for is the best possible fit for your computer. If you're working with 6 inches and smaller parts, getting down into the tenths is no problem. But if you're working with 30-inch or 10 feet parts or something like that, you don't want to be in the tenths and stuff like that. Otherwise, it's going to bog everything down. So what you're shooting for is obviously quick response and everything. I have a 3D mouse right here, and if that was really, really tight, it would probably jerk a little bit or run a lot slower. Okay, so I forgot to mention that it does affect 2 things. It's not just the look, but the performance of your computer. So I think that answers it. What do you think?
Absolutely. So the tighter the tolerance, the more horsepower is going to be required for the machine.
Absolutely.
The end result is still going to be the same for you guys.
Yes. The only time a tolerance is going to affect it is if it's inside this tool dialog box here. Then that will affect the actual toolpath. Any tolerance outside of a toolbox or a toolpath cycle means nothing. Well, it doesn't mean nothing. It just doesn't affect the G-code. That's all.
Yep.
All right.
And kind of what Darrin is talking about here is like when we were looking at the HSM, the HSS, you guys have that tolerance that's built into the operation. That tolerance will affect your G-code. But
100%, yes.
With the stock and target are not going to affect the G-code. So
now, if you're cutting splines, because obviously when you cut an arc, you don't need a tolerance. Because you're cutting IJKs or Rs, so it knows how to do an arc. There is no tolerance to mess with, but if that's a spline, then there will be a tolerance, and I forget where it's at now. There is a tolerance in here where you can adjust it. It might be on the first page. Where is it? It's my advanced on. I'll have to find out. I don't know if it's in face fill because you're not going to cut splines in the face fill generally. Yeah. But anyway, there is a tolerance when you're cutting splines. And sometimes it's when you're actually in the geometry picking it, it'll be at the bottom of the dialog on the left-hand side. So, but again, it's inside the dialog box of the toolpath. So going back to the templates, the only thing that the template isn't going to set accurately or at all would be geometry and levels, because generally that's going to be on a different part. So I picked my geometry already, and then I can just pick my levels from my part. That's why I prefer to have a 3D, but this could just be a sketch. It doesn't matter. And you don't need to use these buttons anymore, just so you know. Simply put your cursor in there, select the top, put your cursor in there, select the face where you're going to. So basically I'm starting here and I'm going to there and I'm done. So, we can run that in verification now. Now in Solid Verify, how this part looks, now this is simply square, but if I had rounded corners on here, the tolerance we set here in the stock and target matters. However, when the tool starts touching this stock, that tolerance is right here. And it almost always sets at that value. Like I said, I generally keep it down in about there. And I'll just show you. It actually is not going to matter on the face mill. So we'll go ahead and do a quick eye machining toolpath on it so you can see that a little bit better. So let's do that. So now eye machining is definitely one of the toolpaths I use a lot. If there's just no better way to rough than in 2D, or even in 3D, you can actually rough out 2 parts with the 3D eye machining, but it is just roughing. And then you would go ahead and finish with pocketing or profiling or something like that. I prefer to use 2D iMachining with 2D parts. Yes, there might be a little more picking because you're going to be picking the edges. As 3D, it always works, just like in turning, it works from stock to target always, but it makes it very easy because you don't have to select anything unless, of course, you want to keep the tool within a certain area. So 2D iMachining. Definitely get used to it. They did.
Since we have that new smart face technology, it makes the 2D iMachining much easier to grab chains.
Yes, yeah, the smart chain thing is very cool. I'm glad they added that. They've also added this dashboard. It's been in here for a little while, but not super long. But basically, anytime you see a dashboard, it's going to give you all your important information all on one page, so you can see it real quick rather than going all the way through this if you didn't want to. However, I'm going to go ahead and go through it. We also added rough and finish not too long ago, simply because the tools last so much longer. You can, do 1 off, 2 off, 3 off part, no problem. Your tool's going to be brand new when you pull it out. Now, of course, I'm talking about a part like this. It's 40, 50 inches in length, and you're cutting a lot of material out. Then, yeah, you probably want to do a rough, rest, and a finish with different tools. But I'm going to go ahead and do that. We'll start with your geometry here, but it is actually quite easy on the dashboard. You might get used to that because this could actually help you program a lot faster, and then keep templates in mind as well. But let me show you, if you did set one up and you didn't have a template, how saving copies can really advance your workflow and your speed as well. So with the geometry, I'm going to go ahead and pick my outside edge. Okay, and I'm going to mark it as an open chain. It tells the system the tool is allowed to cross over. It tells you where the material is and isn't. So that's definitely something you want to do. Chain your part and the areas you want to cut out. Okay, always, this is very important. Not probe. Give it names, because if you don't, it's just going to be contour. I totally spelled that wrong. Contour 1, 2, 3, 4, so on and so forth, and that requires you to have to take the extra time to hit show and highlight it. Or if you have a bunch of them and you need to go down through the list, you can do that. But if you just name them, you know what they are without having to use any of the extra buttons. All right. As far as tools go, I don't know if there's any real feed and speed tricks, but I would, if I were you, build yourself just a basic library if you're not already using them, which I do. All my go-to tools are always listed, together here. I got my probe, my face mill, my end mill, all my basic tools I use on just about every part. So I'm going to go ahead and just import those. And you can always clean those up later. That was a duplicate right there, because my face mill actually brought in my tool. And you can elect not to bring the tool in, because there's a little checkbox at the bottom when you save a face mill to say, go ahead and include the tool. I don't need two of these, so I'm just gonna get rid of it. Right now, I'm just gonna grab me a 1/2 inch. I'm trying to think if there's anything in here that, not really, that I need to talk about, so we'll move on from there. And as far as levels go, you're just gonna pick the maximum. The 0 is fine, that's where we're starting. And I'm going to go ahead and pick down here. In case you guys are wondering, and if you haven't run into this, there are 3 ways to pick depths. You can pick a depth using a face, and notice how it turns yellow. You can have any color you want, but that's actually remembering the persistent ID of that feature, of that face. You can also pick a vertice. The vertice will also remember. It's interesting that it's different. It might be down a little bit lower because it starts to bend, but or you can pick an edge. A vertice or face remembers the ID, whereas the edge does not. That simply means that, let's say, for instance, I picked the top vertice here and the bottom vertice here, and then I put in a -100. If this wall gets thinner or thicker, my tool is always going to go down 100 thousandths past that if it changes. But if I don't have these IDs associated, then if I did put an extra 100 down here, and say this was 125, I would only be doing a total distance of 1 plus 125. It's only 225. If that went to 250 thick, I wouldn't be cutting the whole thing. You'll get used to that. Most of the time, I'm just picking off of edges, because the other thing about that, when you go into templates, personally, if you're going to write a template, I would recommend not selecting vertices, picking edges, because then those values aren't tying to a certain ID of some other file. So I wouldn't do it that way. Anyway. I got off a little sidetrack there. What we want to do, go ahead.
No, that's a good note there, because I guess even myself, I always pick off of a surface, so I keep it associative. But yeah, that makes sense if you're picking off of a surface and you're using that as a template, when you guys go to bring in that template, it's going to try to be associative to that original face. Well, that original face obviously isn't there anymore, so it's a great point to know there.
And a lot of times the system can find your values for you. About 50% of the time that comes in already populated for me. Why, I don't know exactly, but it does. And I want to go a little bit further, so we could put a negative there. You could just add it to right here. I'll just go an extra 50,000. All right. Everybody's pretty much aware of iMachining, so I'm not going to go through too much of what's happening here, but I will tell you that if you're not getting the perfect result that you're looking for, the first thing that I would change with this would just be the step down value. And you can do that by a step down amount, or you can do it by the number of steps. And every time you do that, it may increase this. So let's say I did step downs and I did say 4, okay? It will get thicker on this, what's it doing here? Yeah, 2.4. Let's try that. It should get thicker. What's going on here? Oh, all right. Step down. No, number of steps is what I meant to do. Sorry. So there are 4 step downs at 322, and notice how the side gets thicker. That's the way it works. But sometimes this ends up into a better result. I would never recommend doing like that. I'm just saying, in a deep depth of cut, you might, even though it can do 2 inches, you might think about doing 1, because you can actually get faster cycle times, believe it or not. So anyway,
I don't know if I mentioned when we were doing the night classes before with the iMachine, but we have the red, yellow, and green. Green is always optimal. And the best way to find out, a lot of phone calls that we get is, what's the best tool to use for iMachine? Well, it's going to tell you by if it's green, yellow, or red, and that's all based off of the ACP. So maybe you guys are running a high helix, and maybe we shouldn't be running a high helix, or maybe we're running a 2 flute and we should be running a 5 flute. So kind of play around with your number of flutes, and your helix angle is really what's going to control that, red, yellow, or green for that ACP.
Right. The ACP. Yeah, the APC stands for axial contact point. Basically what it means is how many flutes are fully engaged in the material at one time. Now, what happens with the green, the yellow, and the red is basically when you go to yellow, it's more of a less even number of ACPs in the cut. And the more off value you get as far as even versus odd would be lower. And also, if you're just taking a small depth of cut, you're not having a whole flute in there, so it's going to turn red. All it means, and don't get panicked about it and go, oh my God, it's red. It just means your tool life isn't going to be optimum. That's all it means. Now, what he was talking about, Kevin, is that there are 5 parameters on the tool that iMachining looks at. Now, we look at 3 on the machine, 1 on the material, 5 on the tool. The ones on the tool are the diameter, obviously, the cutting length, the number of flutes, and then in your iData, you're looking at the makeup of the tool, okay? And you're looking at the cutting angle. 45 is basically standard. Now, what I would say that I don't like 2 flutes. I think they're loud, and because they're opposite each other. I like 3 flutes when it comes to the softer stuff, and 4 to 5 flutes when it comes to the harder stuff. If you're picking a tool for iMachining for aluminum or something soft, what I highly recommend is polished rounded flutes. You don't want a cheap tool. I could name a few, but I'm not going to. That when the material hits that flute, it has to do basically a 90 to get out of there. The best tools are at least rounded, and then they're polished if they're really nice tool. And I'll tell you one that works really well is a 1/2 inch Blizzard tool. That thing is beautiful. It's quiet. It runs great, and it cuts a long time. The coatings don't matter. We're not even paying attention to the coating. Okay. In harder materials, coatings matter. I would still use the coatings. In aluminum, you don't want coating, because coating actually works better the harder, or the hotter, I should say, like TICN, talon coated. The hotter it gets, the harder the edge becomes. So in in harder materials, that's a great thing to use. But when it comes to aluminum, it doesn't hurt it, but you can actually get a better result if you don't have coating on it, because coating actually rounds the edge a little bit. So you want to stay a little sharper in aluminum.
Let's just do a little a backup here. Darrin, how many years machining experience do you have?
30.
Okay. So, and guys, definitely feel free to pick, Darrin's brain, because he's been machining for almost as long as I've been alive. Sorry, Darrin.
Thanks. It does not mean I know everything. Trust me. I know you guys have experienced your own stuff, and I'm sure you have your own insights to that. I'm just telling you what I have found.
Yeah. So what Eric is asking, traditionally, this is what Eric's writing in here. Most experts recommend 2 to 3 flute cutters in aluminum for good chip evacuation, but I'm usually cutting really thin parts, 0.5 or smaller. So often I have red cuts that would it be better to try cutters with more flutes on those thin walls versus less flutes? Yes,
more flutes. I would definitely do that. So. Absolutely.
And Ronnie, are you talking? Ronnie was saying he found out that inch per tooth is faster than inches per minute. Are we talking iMachining or just general machining?
Oh, is that a question for me?
No, he just said.
Are you asking Robbie?
I'm asking Ronnie.
Ronnie, sorry.
Oh, when changing the surface footage. Okay. For any operation. Okay. Yep.
So we're talking about footage here. You're saying what is it?
Versus using inch per tooth is faster than inches per minute. Only have to change one and not both.
Yeah, these are just the way this works. Regardless of what's faster, feet per minute and RPM, as you guys know, are linked to each other. So you can type it in as feet per minute or RPM. That's up to you. Or if you're used to seeing inch per tooth or inch per minute, that's up to you. You can program it however you want. So I'm not quite sure the question. Did you understand it, Kevin?
Yeah. Ronnie's grinding his gears right now. He likes to get these. He likes to stump me.
Oh, Ronnie's been at it for a while too. He knows what he's doing.
Not true. All right, well, we'll keep rolling on here, Darrin.
Okay. Anyway, where am I? Let's close that. I was done best for that levels. Where are we at? Okay, we were here. So basically, when it comes red, yellow, or green, it's really talking about tool life. That's all. Green is obviously the best, but I couldn't quantify it for you. Green versus red, how much longer is it gonna? I don't know. Because the technology is still great the way it cuts, because we're managing the side engagement rather than a depth cut. And the best thing about all, honestly, is the fact that we don't bury the tool anymore. Now, I do want to show this in case people haven't seen it before. Why this technology is amazing is, let's say that's the wall you're cutting. Okay, and then we have a tool. Then we have another wall. Okay, and then we have material. Let's say the material is going this way. Actually, we'll undo that. Let me do this. Okay, and then.
Just to know your drawing skills.
I know it sucks, but you can't put lines on top. Like, let's say it's the same amount of material that you're taking off. The problem with traditional machining is this. It's simple, and I know you guys know this. I know this is the wrong size tool. Sorry. Let's do it again. All right. So what we're managing in iMachining is simply a cutting angle. Okay, we're managing that right there. But see, once you hit it with the same exact material on that side, the over-engagement of the material of the tool is detrimental to that tool. We've done 4 years of research on this and seeing what happens to this, especially as we're going, this direction. What happens to the tool at this point right here, this pressure vector, is horrible. So we don't go over 80%. You will never see this, even in aluminum, ever get past 80%. 85 to 90 is where all the bad stuff happens. So what I'm basically saying is, when you go into those corners and hear those squeaks, you're basically hearing your tool deteriorate. Yeah, because it's creating micro fractures. It's heating up and cooling it down real fast, taking smaller depths of cut, all that. Anyway, I'm not going to go any further now. I know you guys know that, but let's where was I at? Let's go ahead and leave 10 for the wall, and we were going to go into solid verify for some reason. I don't want to get off track here. I don't need to talk about that. Simulate, solid verify. Now, there was a reason I came in here. Oh, yeah, that's right. The tolerance that we were talking about. Okay, so basically what that tolerance is, let me pause it right here. Okay. This tolerance, this accuracy right here, so it's a tool facet tolerance. So if we look at the tool, it's the facets of the tool, which means wherever this touches, it's the same faceting. That's harder to see on that one, but you're basically getting the same faceting that you see on your tool. That's what it refers to. So the tighter the tool, the prettier your part looks. Let me go ahead and play this out.
And this has nothing to do as well with your guys' G code. So
correct, no bearing on it whatsoever. But it also plays into, so there's your tolerance. You know, you can see your facets right there. That's a little better. When you go to use your compare, if anybody ever uses compare, I gotta explain this in case you don't know exactly how this works. Everybody knows that computers are binary. They're ones or zeros. That's it. Every little thing in your computer, everything, all it is a switch to flip that dial up or down. It's on or off everywhere in the computer. That also means, in the early days of programming, they had seminars about GPP faults, which is basically anytime you divide or times by 0. Well, this is all in line with that. Basically, what I'm saying is, if we were going to do a compare and execute this, you're going to see, notice how this is red, green and yellow? That's because of the tolerance that you set up here, and that accuracy, that's the tool's tolerance. And you can see it waffle between green and yellow. Now, does that mean because all yellow is between 0 and a -5? All the green is between 0 and +5. And you're thinking, well, wait a second, am I off by, I could be up to a -5 and a +5? No. That GPP, going back to that, you never want to divide or times by 0 in a computer language, otherwise you get a GPP fault. So, being that as it is, the value that you actually cut that tolerance at, or the value that actually came out that you actually cut, could be a positive 0.000000002 or 10 or 15, doesn't matter. It's way past the tolerance that your machine is going to anyway. So essentially, you're right at the surface. However, it turned green because it was a positive value. It was between this and that. That's the same thing for the opposite. If it comes out in orange, then you know you're between 0 and that. Now, if you want to check it, now that we have that set at 5 thousandths, the lowest I can go here is a half a thousandths. Sorry, that's a half a thousandths up here. Anything lower, like let's do 4 tenths, I should say, because that's what we're at. And if I execute this, notice how it's now coming out looking like you got a negative value. You don't, because this value here, which is 5 tenths, this can only work down to within whatever that value is. So if you want to work down to within 1/10, you're going to have to set that at 1/10. Now, I caution you against this unless you've got a really nice computer, because we will take it down to 1/10. We'll take it down to 1/1,000,000th or beyond if you want to. Okay, so we don't. A lot of CAM systems will lock these out, and they won't let you do something like that. Okay, that's insane. You can do it if your computer can handle it. I don't recommend it. Okay, so just know that this value, you can only go down to within this value up here. Okay.
Yeah, and then for the solid verify stuff in here, and we're kind of getting a little off subject here, but for all these little icons that are showing up for you guys in here that Darren's talking about, like with the stock target comparison, holder, all that stuff that's in here, we actually are going to be going through that next week in the night class for you guys. So I know there's always been a lot of questions of, I see all these icons, but what are they doing for me, and how do I use them to benefit me? So we're actually going to be going over that next week for you guys.
Oh, that's cool. Yeah, that'll be nice. I know most of them. I don't use them all, but that's probably the most important one, but I won't talk about it because you're going to do that next week. So anyway, moving on. Now here's how I can program faster. I use a lot of templates and I use a lot of saving copies. I've just filled everything out, and that could have come from a template, so it could have made my life even easier. But I filled it out once. It took me a minute maybe. Now I can just simply do a saving copy. So anytime you do a saving copy, it creates a brand new one, exactly identical. And or if you use a template, either one, the only two items you have to check is geometry and levels. I'll also tell you this. Once you pick the geometry, so if we go into the geometry and I say new, and now I always pick areas that have already been milled out and I mark those open, okay? And then I want to chain this pocket here. Now, and we'll call that pocket. So I like to name my stuff. Now, if I go to my levels now, it's going to call me a liar. No, it didn't. Good job. So basically, because my upper level has not changed, it actually found the next level down. I can test that by putting my cursor in here and selecting the edge. It's still 875. So really, the only thing I had to do is I did a saving copy and I changed my geometry. Everything is identical, but I get a different toolpath. Okay, and I can do that again for the floor. Save and copy. Now this is really neat too. I'm going to check just the geometry and just the levels again. So my new geometry is going to be the floor. Okay, and then you guys know that you can go up and down because it doesn't really matter what it looks like from the side view. It matters what it looks like from the top view, okay, in 2D. So, and I can, let's see, I can do that, or I can do here, I go up, down, doesn't really matter. So I'm going to chain those two, and we'll call that floor. Now watch what happens here. It still thinks we're coming from the top here down to here, and that would be 1 1/8. Okay, but if I put my cursor here and I actually pick the new upper level, I'm not going to do it yet. Watch the bottom level change. It'll actually find it. Boom. It found the next level down, so I don't even have to do anything there. Again, save and copy. If you're paying attention to these numbers, they'll actually work on your behalf. And if you're pocketing something or profiling something and you want that depth, always chain the bottom and it'll automatically populate. Now, this real quick, island moding, if you want to speed up your actual programming, or not programming time, but your cycle time, in a shallow depth of cut, which is only 1/4 inch, you can turn this off. We leave it on, but that's something that you can do in a template. You can come over to your technology and simply turn that off, save it as a template, so it's always off. The reason we leave it on is because that's actually a better way of cutting if you're in a deep depth of cut, because the tool stays engaged more often, and then we get into this ray style tracking. It's faster. However, in a shallow depth of cut, I don't need to do this. And so I can actually make it run faster. Now, it runs the same time. It basically will run the same regardless of, well, the depth will change the feeds and speeds. However, you're thinking, well, okay, well, would this increase or decrease the overall cycle time? There's more toolpath here, so obviously it's going to increase, and I'm not really worried about it because it's only 1/4. So, like I said, I'm going to turn it off. Hope that made sense. I'd prefer to do it that way. That's more of a D-slot style cutting. So saving copies are definitely something that can really save you a lot of time, and then some of the things that happen with it. But again, if you want to set up your templates to turn on and off things, it's definitely a good way to go.
Yeah.
Now, there's,
as you guys are kind of going through programming parts, I know like Ronnie's got some pretty crazy, nasty looking parts that he does every once in a while and stuff. But if you guys are doing a lot of like family of parts and stuff like that, definitely, it's like setting up your tool library. Take the time to set up your tool library of all the tools that you have in your shop. Excuse me. And then also take the time to, as you guys are going through these parts, create the templates for these ones, because, as you guys run this on the machine, Eric is saying, man, that sounded great. I had the great, the surface footage was good. My step downs was all good. Create that as a template, and, just remember that you have that as a template. So when you go to run that same tool again with a similar pocket, you can just grab that, and it's automatically going to have your tool. It's going to have your speeds and feeds of that tool. Everything's going to be preset except for, just like Darrin said, the geometry and the levels. That's all you have to set. So definitely use those templates as much as possible. And Darrin, would you say that you use the templates more than anything, or what's your take?
I use a lot of templates, but I use saving copies all the time. I mean, that's my favorite thing to do. And sometimes I'll even jump up here and do a Control-C, Control-V, because you can do that as well. Even from one setup to another setup, I can use it and just simply change the coordinate system. So if I like it, I just come up here and grab that one. It's got my right tool and everything, and I can copy it down here. I do a lot of copies, now, the templates that he was talking about was not just inside the individual toolpath, but multiple, like let's say you wanted to do those. You right-click and you create a template here. This is where you can check include tool data, so it'll remember your tool. But here's what I recommend if you're going to do this. Give it a really good description, because give it the depth. Give it, especially if you're doing like a spot drill, a tap drill, and a tap. Give it the exact sizes, all the information you need to know, so that when you go to use that template again, you've got it visually. You can grab it, pull it out, and use it and apply it to another part. So these can be pretty complex names and stuff, but you want to include the data or the tool data probably. So, and then they'll show up. By the way, they'll show up right here. Create template. They'll show up right over here under process template. Now, be aware of this. Some people have created a template. Let me do it this way. Let's do a pocket or a profile, okay? And then if I go to look for my templates, where are my face templates? Well, they don't show up because I'm not in a facing operation. It's only going to show my profile templates in a profile operation and a face in a face operation. So if you've created them, you're like, I don't understand why they're not showing up. That's why, because you have to be in the operation, okay? Other things to speed up your programming time, and I'm not saying all these are great and you have to use them all, but there are some pretty cool things in here. I would like to make broaching a little more robust, but I'm glad that we have it. There's a lot of ways that you can do slotting, and a lot of these use some machining type toolpath as well on them. I personally have slots like this. I use profile, and I do a ramp down just like an O-ring grooving. But O-ring grooving, let me just show you that actually. What's nice about this is it actually tells you what to pick. It's visual. We have like 4,500 pictures in the product. So it tells you to pick the two top edges. So if we come over here, and by the way, if it's a straight O-ring, you can grab the bottom ones too. Oops, I got to do this. You can grab the bottom edges. It doesn't matter which one you grab first. It doesn't matter the direction of the arrows. Just grab the two top edges or bottom edges. If it's a dovetail, you want to pick the top edges for sure. Okay. Let's go ahead and do O-ring. Now, what I like about this is very similar to a template. It's similar to iMachining in that you're going to fill out geometry tools levels, and then technology is going to kind of take over for you. So let's go ahead and do tool. And the best thing about this is you don't have to figure out, okay, how wide is my slot? You need to put a tool in that'll fit, but you don't have to know the difference, and this is why. After I pick my level, so we're going to start here, and we're going to go down to here, and I can pick the edges too, but what happens is that it's looking at all this stuff, and now based on that tool, it's saying I'm going to go ahead and drop 15.5 thousandths per pass. It figured that out for me. That's what it wants to do. Now you can increase that. You can overwrite any of this. But here's the best part about it, about speeding stuff up. Say you want to do a wall finish and a cutter comp. You don't have to figure out your straight line move, how long it needs to be in order to turn cutter comp so you don't get an error on the machine. You don't have to figure out how big of an arc it needs to be. Actually, let me turn that off and let's first do this so you can see the ramp down. Okay, so there's the ramp down. Now, if you decide to go ahead and do a finish, we need a straight line move to turn cutter comp on, and we need arc ins and arc outs in order to do finish passes. That's where it comes in handy and does it for you. So you don't have to think about it. Now, you could do this with the profile, but then you'd have to, figure out your arcs and stuff like that. It's not that difficult. It's just faster in here. That's all I'm saying. So definitely, find the ones you like.
Yeah, and I would say this is definitely a one spot where it gets majorly overlooked inside the software is the toolbox cycles. There's a lot of really nice stuff to help you guys out in there as well. And, Darrin likes the O-ring one. My personal favorite is the additional zigzag slot for doing slots on. It steps down in a zigzag pattern, but also takes into factor like an iMachining doing like a morphing spiral in there to get that slot wider, and then does one final finish pass. So
that sounds awesome. I haven't used it either. Are you talking about this one here?
Yep.
Oh, okay, that's cool. Yeah, there's some pretty neat stuff in here. I mean, they put a lot of thought into them. Basically, I think it was last release they had 12. and then they doubled that for the new release, and hopefully another release will have even more in here.
Yep, so there's quite a few more that they even added in there for, especially with the 4 nubs.
Right. For 18?
Yep.
Cool. All right. Well, that's awesome. Obviously, one of the fastest things to do is your automatic feature recognition. We are not known for feature recognition. However, I think we do it better than everybody else, not because I work here, but because we don't have 15 levels deep you have to go in case it doesn't work. So, and here's the other benefit of working inside SolidWorks, especially if you have a native SolidWorks file. We're actually taking the criteria from the actual hole wizard that you produced that hole with, whether it be a tapped hole or counterbore, countersink or whatever. We're taking that information and we're simply using it to create everything for you, including the tools. Now, how do we do that? Of course, we have to have a dialog box, but we only have one. We don't have 15 or 20 or 25. If something goes wrong, you only have to look at one thing. If actually, you don't even have to look at that. You could just open up the toolpath and change it. For instance, feature recognition, hole wizard process. Right now, this is our first iteration of this, okay? We put it on hold, and it's been out for a couple of years. We wanted to see how it did, and now they're starting to work on it again because people really like it, and it works it works fantastically out of the box. You do not have to set this up. It works just like this. I didn't have to customize it for this at all. I built the part, and I tried it on it, and it works. So simply put, you say a tapped hole, you pick a tapped hole, it's going to find all the other holes that are identical to that hole, depth, diameter, everything. Now, once it finds it, it'll turn them purple on mine. It may change colors on yours depending on what you have, and it'll turn this little check mark green. As soon as I hit it, it's going to build the tools mathematically and the operations for you based on the actual criteria that it needs right in here. If you happen to have the tools in your library, it will use those tools, okay? But if it doesn't, it'll create them. Now, can you replace these? Absolutely. Here's the other reason why I think it works better too. In most other ones, I'm not saying all other feature recognition, if something's wrong in here, you have to delete these, go look for that problem in the database somewhere, fix it, come back, and then rerun it again. In ours, it's just a toolpath. You can come in here and adjust anything you want. Cool thing is you could start out with a quarter 20, I think that's what these are, quarter 20s, and then you could manipulate, go into each one of them and change them around, make it a tap for a helicoil or something, and then come back and create your own template. Now, that's a simple way of doing a machine process, and I haven't even talked about that, okay? And I'm going to show you guys, actually, well, let's do one more of the counterbore, and then I'll show you guys the 7 different ways that I know of programming faster. And some will work better for you and others won't, but I'll still tell you all of them that I'm aware of, if I can remember them all. So I'm going to go ahead and grab that counterbore there. Again, it's going to find, why is my mouse not working? It'll find it, and as soon as that turns green, there we go. Found those holes, select OK, and it'll create your tools for you, okay? Now, before I go any further, there are 7 ways to program faster, not even using the hole wizard or anything like that. Templates, one of them, okay? Saving copies are 2. Machining processes are 3. Creating a multi-process template is another. Then you can do things like this. Let's say all these tool paths, in some form, you probably can use on a different part. Well, what you can do is just take all these tool paths and apply it to a new part. How do you do that? Well, you first come up here and you save this job as a new name. This one's called gate box, but let's say I'm doing another box of some sort that's similar, or maybe it's not similar at all. It doesn't have to be. I do a save as, and I rename it to the new part name that I'm going to open up. So I start with that. It's going to close this. It's going to open up a new project with all this stuff in here with a different name. Then you come up here again after it's open and you say change model reference, and you can actually pull up the new part name. Now it closes it again. It pulls up the brand new part. It has all these toolpaths, and now you can take these and just simply apply them to that part. You'll have all your tools, all the other feeds and speeds, all that stuff in here. Again, like a template or a saving copy, all you have to do is change your geometry and your levels. That's all you have to change. Okay, now you might want to change the tool because that particular part's got a little smaller, but that's just one way of doing it. Now, the other great way of doing it is also in configurations. Guys, if you're doing a family of parts, this is all world. This rocks, okay? And I'll just show you real quick. And I built this part. I didn't build it specifically for configurations. I put configurations in here. A lot of people will build their parts because something doesn't work and they'll adjust a little tweak here or there. I didn't have to do any of that for here. So basically, what you have to do, because right now I'm set up to look at the parent of the SolidWorks file, not configurations. You can either look at the parent configuration or you can look at the current configurations. So this is looking at the parent right now, and I'm in semi-automatic mode. Let's say I want to look at the configurations and I want to be in fully automatic mode. So I'm just going to simply switch it to current configurations, and I'm going to turn all these on so it updates automatically. Now what you must do is I'm just going to rebuild and save it. I think you can just exit, but I always end up saving it. Okay, and then opening up, just open it up again, actually. That's all you have to do. Now, by the way, guys, you know that we don't have a save button technically. We have a save and a save as and a close. That's proper way to close it. Save as is the proper way to rename it. However, if you use save as, save all from SolidWorks, it does save our project. Okay, now that I've set that up for a new part, now watch this. I'm going to go ahead and turn all these on. Okay, so that's all the toolpath for this particular part. I can jump into configurations. I'll go to my worst one, which is this one's a lot smaller. Okay, it's coming up saying, hey, you want me to check the synchronization? Yes, I do. Obviously, I've changed my toolpath here, so yes. Now I'm going to come back here and see if I can get that open. And what it's going to do, it's going to look at the new configuration. It'll walk through there and reset all that for me. Now, there are some things that can happen. For instance, on this part, I could have adjusted it to make it perfect, but I didn't want to because then I can't show you this. Let's say I go back. Okay, that part got really small. Let's see if I can get back here and come on, click. There we go. See, this one right here didn't fully regenerate. You can always hit the little plus sign here and it says floor. Okay, something's wrong with the geometry, the floor, because I named it floor. And what basically happened is when I shrunk it down, this little edge right here, and that might be a bug. It's possible, Kevin. That's up to you to let me know. But basically, this disappeared, and then it came back. Okay, technically, it should find that edge again. So I think it actually is a bug. But to fix it real easy, you just simply go to your floor geometry and edit and just redo it. Just repick it. So we'll do this.
And one other, I guess, easier way that Darrin could kind of gone about that one as well is if you, like Darrin did, he hit the plus button down, but you can actually just right click and modify the geometry from right there and not even have to even go into the operation as well.
Yep, something I never do. See what I mean? I don't know all the tricks, but yeah, you can right click and edit. Generate a sketch, show, synchronize, whatever you want to do. All right.
With Kevin and Darrin, you guys will learn all the tricks then. It's all,
Well, there's so many ways to do things in here. Just like in SolidWorks, you just have to decide what works best for you. Now, last thing I'll show you guys, it really is amazing. If you haven't been using it, you should, if you need to. The chamfer is just really cool. That's a user-requested feature. Multiple people hit us up on it. Obviously, it's great because you can pick individual edges, or you could just click the whole thing and let it parse the model, and then you can come in here and delete the edges you don't want to chamfer. Pick a tool, preferably something small so you can get nice and close to the wall. That's why I always have my certain tools around. I've got a little 1/8 inch with a 45-degree on it chamfer tool. Looks like that, real simple, okay? And then put in your chamfer size. You don't have to have the chamfers on here. Maybe you just want to break the edge. There you go. And what's cool about this is it's a 2D toolpath, yet it'll give you all the different depths and stuff. And that's usually a no-no when it comes to 2D toolpath. Only 3D toolpath does that. Normally, you have to do these individually if you're going to go at different levels. Yep. But that's going to speed stuff up for you guys a lot. Now, I'm sure there's a lot of other stuff, but we're about out of time. Any other questions? And
now's your time, Ronnie, to pick Darrin's brain. Or anybody else.
Ben, Carlos. My brain on several occasions.
I'm not seeing any questions come through here. And then
There's been times where.
Oh, go ahead.
Go ahead. No, go ahead.
All I would say is, you know, I get getting a lot of feedback from you guys on using that other simulation software, which is called Eureka. That is coming up on the, God, I always forget the date. I think it's the 12th. Yep, thank you, Ronnie. On the 12th, and Ronnie is a customer of ours. I love giving Rodney a hard time, but he's going to come in here and show you guys kind of how the Eureka software works, built in with the SolidCAM for you guys as well. So for those of you guys that are asking about when we're going to show that, that is coming up on June 12th for you guys. So
now, is Eureka, is that one of the G-code simulations?
Yep.
No, it's not. This is.
Yep.
Oh, it is. Oh, yeah, there it is.
Eureka. Yep,
Okay.
it's right there.
So basically, when you generate G-code, you can have Eureka automatically open up your G-code, and you can verify directly from there, which is nice.
Yep, and it's going to pull
or with Vericut or any of the other ones.
Yep, and what we'll actually do, guys, I still got a couple guys, or there's quite a few guys still in here. We do also have Octopus in there. Octopus is more is G-code as well, but it also deals with like robots. With welding and so on and so forth. Do you guys have any interest in seeing how the Octopus works with the SolidCAM as well? Just kind of throwing that question out for everybody here.
Yeah, go ahead and vote. I'm gonna just give you my opinion on you know, like Vericut is awesome. It's hard to learn, but it's awesome. There are two trains of thoughts here. Some people say or swear by G-code, and they say that's the only way you should be verifying. And then you've got our stuff, which is machine simulation. There's internal machine verification. Just FYI, both sets have to have a reverse post. The reverse post is what actually makes the G-code work in the machine, and it also is what makes the ink file internally work. So it's really 6 in one hand, half a dozen in the other. It's what you prefer, but they're no more accurate than the reverse post that's got to be created.
Sure. And Greg says, yep, let's see it. So we'll definitely get that added to the lineup. Any other questions, guys, for Darrin? Hopefully you guys got something out of it. I think, you know, some of the big hitters are, you know, using those templates, you know, using that save and copy button as much as possible. To eliminate, you know, it's all about eliminate the most clicks, and you know, the sooner we can get this process out, the better. So, you know, if you guys have a very complex part file, definitely turn that simulation on your Solid Verify down. That's going to play your simulation through much faster for you guys, so you're not waiting on the facet tolerance there. So, hopefully, you guys got something good out of it. So.
Actually, there is one more thing I want to share with you guys. If you're trying to verify really fast in Solid Verify, there is another way you can do it. This is still going to give your, this can slow it down or speed it up, but what can really speed it up the most, and I will just tell you that ball nose tools are always going to run slower because there's a lot more faceting going on. But if you're already up to level, whatever this is, 8 or 10, and it's still not running very fast, and you want it to go faster, just simply set your general right here. This is showing, okay, this is showing, I always hit defaults, this should say 4,000. 15 frames a second is about the same as 1 G-code line, basically. That's what that says. And so let me hit that, and I'll show you how much faster. Let me go back, and I'll just rerun it so you can see it. I was talking, and I didn't get to change it in the middle of it. So general, let's start with 1. Okay, I'm all the way up here. But now if I change it to show every, say, 30th move, it's way faster. Or 100th move, whatever you want. I think it only goes up to 99. I've tried above that.
999.
Well, I don't see a big difference, so at that point. So up to 100 is what I've seen a difference on, and that's about it. So
yep.
Just FYI.
And Eric is asking, can you show how to do the multiple configurations again? And Eric, correct me if I'm wrong.
How to build them or how to set it?
I think how to set it up in your settings. So when you're doing multiple different configurations, how to have that set up in settings. And Eric, if I'm misreading that, please let me know.
There are 2 ways to do it. if all your parts have configurations, I would go like this. I'd go into your main settings when it opens up, and then go into, where are they? I never set it up from here. Yeah, synchronization. Now I'm in a part which is grayed out, but you can say it's always a current configuration, and then you can check these. Now this one right here, I don't normally check, but I do if I'm going to do with configurations, because anytime you switch, it automatically sees that, and then it synchronizes automatically and it calculates automatically. This is important. So I would check this one and then all three, or all three and then this one, whatever. Because that way, anything changes, anytime you switch to configuration, it'll automatically update. Now this is if you're going to set it from here, if all your parts have configurations. If they don't, only one or two, start your project and then do the configurations from here. Notice how the settings, there's a lot less. Basically, it takes the main settings from here and it pushes down all the stuff that would apply to this part. That's why there's less stuff.
Okay.
Okay, and all the other configurations are based on the whole entire CAM product. So.
Okay, so now go to your configuration tab, and Eric is running a family of parts that are all identical, but that have 3 different thicknesses. You want to show how to add a configuration in there?
Oh, okay, sure. Well, this is more of a SolidWorks functionality, but what I like to do is they always have one that's named weird, and I don't like it. But you can right-click, you can say, oh wait, it's up here, sorry. Add configuration, okay? I always make the names and the description exactly the same, so we'll just call this test and test, okay? Now that we have a configuration, and I probably should show you this on the other one. Yeah, let's do that. Instead of inside of a CAM project, you probably don't want to really do that. You want to do this more on the, you can do it, but if you want it to be more fluid, you're going to want to do it from here. So right click, add a configuration. We'll call this test. This one test. It's just what I do. You can do whatever you want, except okay. Now I've got a test configuration, and basically this state is what the configuration is set at. But if I'm like, yeah, but I want to get rid of these right here, so I'm going to suppress that, okay? But now in this configuration state, I have to take a look at, it's better if you go like this, okay? You'd have to go in here and edit that, okay? It would be better if you did this. How come I can't get rid of it? Oh, because I'm in it right now. Let's go to that one. Okay, let's create this and delete it. The best thing to do is go to the configuration that you want, like let's say here, and then do to it what you like suppressing those holes. Okay, so there's no more holes. Then create your configuration. That would be the, I think this will work. Drive configuration, test, select OK. And where am I at here? What did it do? Why am I on there? There it goes. Okay. So where's my test? Oh, I created it under here. Gosh darn it. Sorry about that, guys. You want to do it up here. Okay, let's go back and do that again. There we are. Now we'll do this configuration from here. I did a derived configuration from a configuration. All right, so now you have that in this state. But if I go to this state, the holes should come back. If they don't, no problem. Come down to here, and you can mess with your configurations when I can find it here. It's been a while since I've done this here. Maybe I have to do it when it's on. So let me go back to here. No? I guess not. Hold on. I'll figure it out. 1 second. It's been a while. Where the heck is that?
You can click on the configuration features.
All right, test. Now this is not what I want. There's an easier way of doing this. I'm looking for it. There's actually an easier way. It's right in here. I can't remember how to do this here. Okay, hold on. Let's try this. Let's go back here. That's on and they're suppressed. So I'm going to unsuppress that. but for just this configuration. So that's what I need to find for this configuration only. Yeah, this configuration, that's what I want. It's suppressed, but no, I want it unsuppressed. Sorry, I'm on that one.
Yeah, so Eric, to kind of answer your question, what you'll do first is you'll have your default configuration in there. Then go ahead and add your like for your family of 3 different parts. Add that, you know, let's just say 1/4 inch thick, 1/2 inch thick, and 3/4 inch thick configurations. Then when you actually click on that configuration, you can go and change that that thickness for each configuration.
There we go. I did it backwards, but that's how you basically do it. This configuration should be the other way around. I want them unsuppressed for this, so I'd come in here and unsuppress it. Then I would mark it as for this configuration. Okay, so that's what I want. Now for the next configuration, you just go in there and click on it, and as long as it's on, you can suppress it as long as you're on this configuration. So now you should be able to come back here, it appears, and back here, it appears. I like it. I think it's always set to all configurations, and that's what gets confusing. Set everything to this configuration, and you can get it to change back and forth.
Yep. And Eric, if you do have more questions, I think he got it, but Eric, if you do have more questions on that, shoot me an email, and I can give you a jingle tomorrow too, as well.
Yeah, and just FYI, when it comes to the actual sketch, let's say you're going to go in there and mess with the sketch. Well, now you're talking a little bit. You have to go on a sketch level. So let's say like that one, edit. So in every one of these, you can actually, there's a configuration right here for your values. So when you go into configurations for individual sketches, you have to do it in here. So you could have one sketch that, but you want the feature there, but the feature's changing in size. You want to do that here. Okay, it's only what I showed you was just the actual feature getting, you know, suppressing or unsuppressing from there. So just FYI, and Kevin can help you with that tomorrow if you need more information on it. It's been a while since I've done it, but that's how you do it.
Any other questions, guys? I don't see anything coming in, but if you definitely have a question, shoot them in right now before we wrap this up. Before we end off here, I'll throw the old sales hat on real quick. And if you guys are looking at, you know, upgrading, make sure you tell your account manager that you want the KevCAM discount. This has kind of gotten, a couple of guys have gotten bought upgrades and forgotten about that. So definitely tell your account manager that you want the KevCAM discount, and they will throw that on there.
KevCAM special.
Yep.
That's what you're about to say. KevCAM special.
Yep.
Hot and fresh, for sure.
Yeah, you pay just a little bit more than everybody else when you get the KevCAM.
Yeah.
If you happen to be on the one with Darrin, yeah, it's going to be double the price. So I'll leave it out there.
No, but also, guys, keep in mind, if there's something you want to try out, we can turn that on for a week or two or a month as far as we'll go. But if there's like, yeah, I really want to try the full HSS or something, we can flip that on for a month if you want to try it out. That's a good way to try before you buy. Yep. And no money has to be exchanged or anything. Kevin can turn that on for you.
Yep.
He's got the power.
I got the power at my fingertips. But all right, guys, we kind of went a little bit over on time, but I think it was all great talking subjects here. So definitely, if you guys do have questions, I think everybody in here does have my email address. I've seen a couple names bounce in and out through the night class here. So hopefully everybody has my email address. And if not, or if you're watching this on YouTube, it is down in the description of the video. So, and like I said before, next week we will be covering what all those little buttons do inside the Solid Verify. So there's been some questions on that, and you guys wanted to see it, so definitely we'll get that shown. And I see a future topic request: making tool paths from form tools. Great idea, Eric. Unfortunately, Eric, as I close this down, I lose this information. So Eric, if you could shoot me an email on that, we will definitely add that into the lineup. So if greatly be appreciated, because I'll try to remember it, but by the time tomorrow morning comes around, it'll be my brain will start over. So, but And I just want to thank you guys for, taking the time to watch these night classes, and hopefully you got something out of tonight. And anything else, Andrew, that forgetting here?
Oh man, we're good.
I was just going to say, if you guys like what you saw and you want to rate what we did, you could use the customer rating here as well. So
Yeah, absolutely. I know Ben's put a rating in, and Ronnie's put one in, and Greg's put one in. Eric, I'm not sure. Have you done one of those customer reviews yet?
Peer pressure. Now you have to.
Yep, now you got to. And
Eric.
If
if you didn't like what we did, then use Kevin's name in here, because I don't want to be part of it.
Eric, I'll send that over to you, and then they send you some SolidCAM swag as a thank you. Kevin's email, let me get it to you right now, Eric. If I can type right. All right, Eric, did you get that? Should be kevin.rankle@solidcam.com. Perfect, got it. Excellent. So yeah, like I said, definitely let us know what we can do to help you guys out as much as possible, and send those ideas. Keep sending me those ideas, and keep this night class going. Or if you guys have something short and sweet, we'll do it for the tip of the day. So I guess with that, we'll let you guys run for the night. And if I don't talk to you guys in the meantime, have a great week, and we will talk to you guys next Tuesday. All right,
yes,
guys.
thank you all for coming.
Yep, thanks, guys. Have a great night.
Thanks, you guys.